Sieve, cryptographically enforce access control for user data in untrusted clouds, by Frank Wang, James Mickens, Nikolai Zeldovic, and Vinod Vikontanath, and me as a presenter, Marco Lanza. Motivation. A sieve method in mathematics, in other words, in computer science, is a simple method for finding prime numbers and therefore can be used in the cryptography system. I guess that's what they're using the word in there for their system to name their system. Sieve is a platform that exposes user data to web service selectively and securely. It is a user-centric storage model where the user can upload its encrypted data to a single cloud store. It would allow users to decide which application access which parts aspect of their data. In other words, the users is the one, not the web server, which is decided what parts are they going to access on this application. Access to cloud storage are not dictated by the user, as I mentioned before, by the web service itself. Normally that's the way it works. The users lack authority when they have to determine how their data share with other web service. That's not good. There are some drawbacks in the cloud with this problem. In other words, if the user lack authority, so in the cloud, such as privacy and security is a problem. For example, government might be able to check on your data, and even the providers might try to monetize your data by doing machine learning. So that's all done in the back. So that's not good. So that's the reason they create so far Sieve, or that's one alternative for this problem. And there's another problem. So far, there's no legislation for this problem related to privacy and security. And it is a very important problem because security, it can be at stake if the user does not have low-level control over cloud storage, since there are no guarantees that the data information would be shared with the other service. So the user doesn't know what happened on the back. Siege, which is a solution for that. It's a new system for delegating access to private clouds. Data use ABE, attribute-based encryptions, and key homomorphism. So it uses those two techniques, ABE and key homomorphism. So far, as I research, there are no solutions out there. However, IBM in 2009 invented the homomorphic encryption, which is a form of encryption that allows the user to encrypt data and perform computations over the encrypted data. It is not feasible because it's super slow or limits the types of computation for the user. In other words, for the it will slow the computation, and the performance is not going to be that great. However, Sieve, in this case, platform provides a solution which is clearly described, and it's not only theoretical but practical as well. So Sieve, actually, it's a solution, it's a platform solution. It's based on IBM originator homomorphic encryption to implement revocation. As I mentioned before, IBM created, but Sieve is based on that, but it's not exactly as the same. Sieve allows the storage provider to re-encrypt the user data without knowing the underlying text. In other words, the difference between IBM homomorphic encryption and Sieve platform is that Sieve is the first ABE attribute-based encryption. stored system which support rekeying of both metadata and the data. So the data, all the information, if it's the files, in other words, the metadata. So the difference between IBM and Sieve is that IBM is only homomorphic, and Sieve, besides being homomorphic, is the first one, and which is use ABE, attribute-based encryption. So that's the motivation behind so far I have been discussed. So the motivation, in other words, Sieve is a platform which has allowed the user to handle the security, which is normally the cloud or the web service, the one to handle. So Sieve is allowing you to do that, and it's based on key homomorphic and ABE. Now the design, how it works, in other words, the idea behind it. The main idea of Siege platform using ABE is that the encrypted data is associated with the attributes like in key value pairs, and that in Siege the user generate their own policies. So it's based in key value pair, and the user is going to generate their own policies, because usually in the cloud it's out of your hand. So the policies, they all generate they will generate by themselves. So you don't have much control over those policies. Sieve use ABE to translate human understandable access policies into cryptographically enforceable restrictions. Unlike prior solutions for encrypted storage, Sieve is compatible with rich legacy web applications that require server-side computations. There are other systems that use ABE protect storage, such as Persona, Priv.io, and Catchit. However, these systems, unlike Sieve, cannot delegate access to services such as arbitrary third party. That's the difference. And now I'm not going to talk about those, Persona, Priv.io, and Catchit, because it's out of the topic here. All of them, in other words, those three, Persona, Priv.io, and Catchit, with the exception of Sieve, cannot recover from the loss of individual devices. In addition, Sieve, unlike the Persona, Priv.io, and Catchit, in case the storage servers are compromised, it will provide a concrete revocation protocol that safeguards the user data, which is good. That's another advantage of Sieve over the other ones, the other systems. Still, how design, how it works. In Sieve platform, users generate their own policies. They are the ones generating their own policies, as mentioned before. Now there's a called OAuth protocol out there. Google App Engine, for example, use it. It's a widely used authorization protocol. That is a set of rules which allows a third-party website or application to access user data without the user to share login credentials. Sometimes you can see that happens. Someone tried to access your email, for example, and ask you for your permission, like a Facebook wanted to go to your Facebook account and etc. This behind the scenes is using OAuth protocol. In other words, the OAuth protocol allows a user to grant a third-party limited permission to access a web application without sharing his or her credentials. In other words, sharing the username and password. OAuth, which is the extension of OAuth, relies on the existence of various trust parties to enforce access policy. In other words, OAuth extension of OAuth That's the one I'm talking about. They look alike, but there's a A and O in there. Um, OAuth, it is written by web service, not by the users. As you can see here, the user doesn't have any control. It does not leverage cryptography to enforce access policies or protect the user storage. As I mentioned previously, the access is not enforce access policies. It's not strong on that. Therefore, OAuth protocol can be vulnerable for data leaks. In Sieve platform, on the other hand, the users generate their own policies, so the user generated the policies as they specify here, and not the web services, resulting in a strong certainty of how the user data will be exposed. In other words, user has totally control how you're going to expose your data. It's up to user. Still on design and how it works, in addition, in the cloud, the user who wants to share his or her data online will keep the encrypted data on a cloud storage provider, but many third parties will need delegated access to this data. By using Sieve protocol, the user do the same, will do the same. You could online, where you wants to share his or her data, you keep the encrypted data on a cloud storage provider by placing the encrypted data on the storage provider, as I mentioned. However, it will never reveals the decryption keys to the provider. Therefore, by using Sieve and in case of storage service being malicious or compromised, the user data confidentiality will be protected. So there's an advantage in there. So there's nothing can happen, behind the scenes, because you have the total control. And as I mentioned, you as a user, it's not going to reveal the decryption key to the provider, whatever your provider for your, where you put your data. Design. It's still design and how it works. The Sieve platform divides its component as a Sieve user client, sometimes you can call user client only, a storage provider daemon, and as an import daemons, which will be running by third-party web services. Okay, the first one, the Sieve client. The Sieve client runs on each user device and provides a GUI, a graphical user interface, for the definition of high-level access policies, and also the installation of the user from the low-level management of cryptography keys and data uploading. In other words, the Sieve client, it's a GUI. Everybody knows, of course, what is a GUI. So in a client, it's there you're gonna define how you're gonna access, how you manage your policies, and also, as mentioned, the installation of the user from the low-level management. The keys creation, data upload, and you're gonna avoid that. It's gonna be by just clicking here and there. You're not gonna see the whole thing behind scenes. It's gonna be in an easy manner. Now the second one, the storage provider daemon. The storage provider daemon works on the communication with the Sieve clients. In other words, you need to communicate, you need to talk to the Sieve clients. The storage provider daemon is the one who's going to work with that. It is also responsible for writing encrypted user data to cloud storage and use the data AB attributes to build an index. In other words, behind the scene is the one responsible, as the Sieve clients is not going to see it. It will be insulated, but behind the scenes is going to write encrypted user data to the cloud. And of course, he's using the data AB attributes to build an index. This build index will allow for fast data retrieval by the import daemons, the third one, the other one. Now, these import daemons, how it works. The import daemons, which belong to the web service, receives AB decryption key from Civ clients. Each of those keys allow the import daemon to decrypt a subset of the user's encrypt data. As you can see, all feed in a group: the Civ client, the storage provide daemon, and import daemons. Those are those that you're gonna need it, in order to use the Civ platform or Civ systems. Another important point: the Civ client manages the conversion of high-level activities into low-level cryptography operations, and the user generates access policies and barely text data. In other words, as I mentioned before, the Civ client, that all this information is insulated for the user in a GUI, is gonna manage the conversion of those the high-level activities into low-level operations. And of course, right there, you're gonna need to tell what is your access policies, because you're gonna manage who you expect to see or data or not. For security reasons, the user's Civ storage is read-only for third parties, where only the user can update all objects and write new ones, which is a good thing. As this can say, it's a read-only, no write involved. User Civ objects can be derived by third parties using their own storage for this data. Okay, the Civ clients handles 5 types of cryptography keys. 5, such as the following: per user AB master key, individual AB decryption keys, users AB public key, per user RSA key, and symmetric key. Okay, design. How it works for those 5 cryptography key. All the cryptographic operations are not visible to the users. This is a low-level operation. That's what happens, a low level. The first one, per user AB master key, helps generate the individual AB decryption key. So right there, it generates the decryption key. The next one, the individual AB decryption keys are given to the web service, because you need to talk to web service. You need of course, you have to deal with the decryption key for both. Users AB public key. You need encrypts metadata blocks together with users provided attributes. Because remember, the C platform, you're talking about attributes. You're gonna deal with the AB, the attributes. The determination of which metadata blocks can be decrypted by the service is based on the web service AB decryption key, since you provide it for them, as I mentioned before. You provide the web service the AB decryption keys. Now, a per user RSA key can be used to sign metadata blocks pointing to data blocks. And the last one, the symmetric key, can be used to encrypt metadata blocks, point to data blocks, and signed by per user RSA key, because you need the signature, and that's the reason you need to be signed by per user RSA key. Okay, and now evaluation the system. How I evaluate the systems. C requires client to symmetrically encrypt each data object before uploading it, and also some fraction of these uploads require clients to AB encrypt a metadata block, which is good. So far the evaluation is good, because you need to symmetrically encrypt data before uploading. Everything is going to be encrypted, in other words. Although clients can upload asynchronously, however, in the background, there are still quite high computation costs for AB. In other words, there's a cost for performance using these systems. So the first was a little, as I mentioned, as a pro, everything is going to be encrypted because you have to encrypt each data. But as a cons, there is still quite high computation cost for ABE because it's based on an attribute. So this is a cons. And as I mentioned, the cons, the creation of a new ABE keys, it's rare. It's not happen often and occurs only when an old service receives modified permissions or when a new service requests access permissions. In other words, it's rare. It can occur, the creation of a new key, and happen when a new service requests access permission or an old service receives modified permissions. And if it is so, if in other words, if it happens, Sieve will pay for generating new ABA keys, re-encrypt metadata blocks, and rekeying, for example, 100 kilobytes data block, as described in the follow figure 6. So there will be a cost in there. That's another cons. It's rare, but it can happen because Sieve needs to generate new ABA keys. Then they have to re-encrypt the metadata blocks and rekey in 100 kilobyte data block for each again, and describe as in the figure. As you can see, the valuation, the operation time when it generates 10 attribute keys, 0.46 seconds. If it's 20, 64. So in re-encrypt metadata blocks, 10 attributes, 0.63 seconds. Re-encrypt the metadata if you have to redo it again, blocks 10 attributes, 0.91. And rekey 100 kilobytes of data block is 0.66. So in other words, there will be some computation overheads for key generation and revocation. In other words, based on the previous information, as I explained, there is a need to use both a hybrid encryption and Sieve's optimization in order to minimize the numbers of your operations. So in other words, you have to use both if you want to achieve you want to avoid some computation overheads. In other words, the performances won't be that degraded. Okay, conclusion. Based on the pros and the cons, as I specified before. Privacy of data is a huge problem in cloud computing. Everybody knows that. From financial information to medical records, sensitive data stored and computed upon the cloud. Computation requires the data to be exposed to the cloud service. You don't have another word. You need to do that. That's where it is. Which may be attacked by malicious applications or insiders, for example. That's one problem right there. In other words, it can be attacked, or someone can use your data, and you don't want that. So the C platforms for those problems, unlike other solutions, is compatible with legacy applications, which is good. It's still a lot of legacy application out there that requires server-side computation. It allows users to expose their private data to third-party web service. It allows using the decryption, key encryption, decryption key, and it is the first ABE systems that can protect against device loss and also supports the full revocation of both metadata and data. So in other words, it's a good thing. Now the problem, as I specified before, there are computation overheads for key generation and revocation when using Sieve. However, by using as a solution, you can use both hybrid encryption and Sieve's optimization at the same time. If you use both, will minimize the number of ABE operations. Therefore, it won't be that big a computation overhead. And then therefore make Sieve platform in general a good product to be used. So overall, Sieve is a good system as long as you follow the to avoid overhead. If your system have that computation overhead by using both hybrid encryption and Sieve optimization, then you minimize the cause overhead, which is the number over E or number of AB operations. References, that's the references I use it so far, as I mentioned in the beginning: Frank Wang, Jamie Mickens, Nikolai Zeldovich, and Vinod Vaikuntanathan. And it was based on Sieve cryptographically enforced access control for users' data in untrusted clouds. That was the paper it was based. Thank you. And my name is Marco Lanza.